understand it, so that's good. It's not too data sciencey. But actually, you guys were lured in with Stijn Tonk, who is not here. So he asked me to give this presentation. So this is all not going to happen. So there will be a talk about fairness in AI, but it won't be Stijn Tonk as Chief Strategy and Innovation. It will just be Henk Griffioen, Lead Data Scientist at Griffioen. And I won't do all the trends on creating fair models, but I'll share some insights on how to create them. If you don't agree with this, please leave the room. Otherwise, I'll entertain you for half an hour. So I think it will be great. So I think the end message of the day, or the takeaway of this day, is for me that we as data scientists, or people working with data and AI, we have to put in the work to not end up in the ML hell, so the machine learning hell. And I got this piece of text from the works of Virgil. So it's from Aeneas' flight from Troy. So Troy got destroyed, and then this is classical work on how he flew Troy. And so it basically says, well, it's easy to end up in hell, and it takes work to end up in a good place. This source also related with the road to hell is paved with good intentions, and I think that's also what we do. We try to build machine learning products and have a positive impact on society, but that might not always be the case. So we have to put in work. And I think, so I got some news article from the last few weeks, and it was not too hard to find some bad examples. And it's quite clear that the impact of AI on society is not all good. So it can really encode and amplify human biases. And we can now make predictions at scale and make decisions at scale, but we can also make automated bad decisions at scale. So we have more power than ever before. For instance, I think this one was the most recent one, the one from the government in the UK. So they deported 7,000 foreign students after falsely accusing them of cheating on tests. And apparently they used an application for this, and this application had a cheating detection error rate of 20%. So that's quite an impact you have then. That's something you don't want to do. And I think also the Dutch government is using on big scale predicting algorithms, and they may not always account for discrimination and racism and stuff like that, so all the biases we have. And the good thing is that fairness is a hot topic and it's gaining traction. So this is a picture from 2017, and we're already two years later, so it can only grow. But still, I don't think it's part of the standard toolbox of a data scientist. So there's work to be done. And I also don't want this talk to be a holier than thou talk that I, from the heavens, preach how you guys should do it. I've also, of course, encountered this. So I also had a client, and someone else made a model there, and it was basically trying to find the best price for the customers. So what should we ask our customers to pay for our product, to keep it a bit abstract. And in there, it worked quite nicely, but they used zip code. And during the presentation, I asked, should we actually be using zip code? Because what this model will do, I think, it will ask a higher price for people in poor neighborhoods because they cannot pay back. So they may not always pay their subscription on time. So we'll probably raise the prices for them. And in the end, they'll have to pay more for all the subscriptions. So they can't pay back all subscriptions, so they get all in these bad debt sectors. So you get like this vicious circle that people get in. So is that something we should do? And at that meeting, people basically said, we don't care. We just want to have money. So for me, that was, okay, that's too bad. And I didn't really push it further, but it was just, I flagged something, but that was about it. So I didn't really totally act on that. So that's something that I also could have done better. So I think, that's the whole thing with ethics. Of course, nobody's pure, but we all have to try our best. So we'll work through an example here, and it's, I cannot use client data or anything for it, so because it's all sensitive. So we'll use a classic example. And for this example, we'll try to predict income from census data. So we have some census data from 1994, and we want to predict if someone has a high income or a low income. And I think it's easy to make a connection to, for instance, a financial institute, where you want to predict if someone applies for a loan, whether someone should get it or not. Does someone have a high income, depending on the attributes you have, or maybe for our tax authorities, what are the expected taxes that someone should pay. So for this data set, what you see here is a snapshot of the data, so a bit of it. So we have the target is the thing we want to predict, so if it's more or less than 50K, and there's data like age, the work class, education, and occupation. So I think that seems like all not too crazy stuff, but then there's also some sensitive attributes, namely race and sex. And we'll see how we'll work with that. So with data science, I think getting a predictive model is easy. You just put in the data, you write some code, and you get some predictions. And these are, if a data scientist sees a graph like this, they're all happy. So they have 85% accuracy, which is really good. There's a confusion matrix over there. There's some more complicated data science stuff that says that the classifier is really good. So all in all, a data scientist can be happy because the model is performing well. But that doesn't necessarily, of course, say that the model is fair. So how to measure fairness? Does anyone have any idea? So which one of the two situations, with this being the decision boundary, which one is more fair, to the sharks or to the elephants? You at the front? This one? And why is this one more fair to you? Yeah, so that would indeed be a good example. And do you have any idea how you would formulate this, or how you would make a formula out of this? Sorry? Yeah, so we could remove the identifiers when making the model, or what do you mean exactly with that? Okay, so we now need to put in like the sensitive attributes in the model, and we should not put them in, right? And then it may be better. Okay, anybody else, any ideas? Yeah. Okay. And do you have any scenarios that you can think of?
You gave a good example from the financial banking industry. If you say, well, low-income people shouldn't get a loan, or you should pay a higher price for a loan, that's a totally different thing. You say, well, we're going to protect you not getting into trouble, or we're going to sell you something more expensive. So it's how you use it.
Yeah, I agree. So it all depends on your use case, what you'll be measuring and how you will be measuring in the whole problem. Here I'll give one example of a measure, and it's called a P% rule. And this is, I think, there's an official institute in the US that has decreed that for loans and stuff like this, this is how you should measure it. And it basically says that, okay, we look at the ratio, first of the probability of a positive outcome giving the sensitive attribute being true, divided by the probability of a positive outcome giving the sensitive attribute being false, is no less than some threshold. And here we would say, for instance, for the sharks, so for the high income predictions, 1 out of 10 sharks gets this high income prediction, while 50% of the elephants they get this high income predictions, and they would then get a P% of 20%, so P is 20. Here it's more fair, because here 40% of the sharks are given the high income prediction, and also, again, 50% of the elephants. So this seems more equally, more nicely, more fair distributed. And so there are more metrics like this, but this one is the one we'll go through with the worked example. And so if you so we looked at the performance of a model, and now if you look at the accuracy, so at the fairness of the model, we're seeing that the model is actually not fair. So at the left part of the picture, we see that this P% rule is around 30 to 40%. So the accuracy is quite good, but it's not fair at all. You can also see it from these graphs. So in general, black people and women, they tend to get a low probability of having a high salary. And this is, of course, all encoded in the data, and it's how the world was when the census was taken. And it's not necessarily how we want the world to be. So we have to adjust for this in some way. So we have this bias in our systems. So how does this get in? So how do we end up in this world? Anyone an idea? Yeah, indeed. Humans are biased. That's one. We encode our own biases in the data, and maybe in our hiring process we have something we don't like or don't like from the same university or not, and we tend to hire those, and it gets fed into the data. Any other ideas? The training data is biased, and what do you mean with that? Yeah, indeed. So indeed, the past is not necessarily how we want the future to be. So we record the past. But do we want to go like that going forwards? And so here's a few examples why bias can be creeping into our systems. So we have the skewed sample, so initial bias that compounds over time. And that's, I think, an example of this, where initially we would predict high income mostly for white males. And that gets like a feedback loop in our system and gets worse and worse. There's the 10 examples that you gave, so a human bias that gets in there, but there's also other stuff like sample size disparity, so minority groups not as well represented, or the data not collected as well. Also, that you might see is data that implicitly encodes your bias, and we'll see an example of this now. So I think last week the Dutch tax authorities were in the news, not really great topic, but it was found out that there was ethnic profiling being done by the Dutch tax authorities. So a daycare center in Almere sounded the alarm when only non-Dutch parents were confronted with discontinuation of childcare allowances. And so they said that they actually used data on Dutch nationality or non-Dutch nationality in a so-called automated risk selection for fraud. So this is a bad thing. I searched for some more news articles, and actually it was just someone with a Excel noting down nationality of people, so it's not really automated selection. But this is clearly a case where we can have an automated system making decisions and biasing or influencing our society. So the first thing the response that the tax authority had was, okay, we'll just leave out the information about second nationality, so just don't use it. And then hopefully we don't have the problem anymore. So Frank Weerwind, I think it's the mayor of Almere, his question would then be, is this enough to assure that non-Dutch parents in Almere will not suffer another tax injustice? Anyone any idea? Is this enough?
Maybe if they all live around in the same zip code area and that's used, then they can still get that bias?
Yeah. Anyone want to respond on that? So.
I was just repeating.
Yeah, so it depends. So I think you're still just using this is probably not enough. You'll have to check. As we said, there can be proxies in the data, so like zip code that can encode for a sensitive attribute, basically. Oh, and yeah.
Depending on the variables that you're using, if they're sensitive or not. Let's say, argument's sake, that it is true that they find out a lot of cases where it's true, so that they're using, in this case, ethnic or nationality as a predictor. If they're not using it and they have a childcare,
Yeah.
then it's even worse. So if you're using this, and it is a very high predictor, then is the question how to interpret it and how to deal with it.
Yeah, so I think your point is there's a trade-off between performance, right, and fairness. And when does your case or your machine learning case still apply? And when is it still fair? And how should you basically take the balance there?
Yeah, because trying to do another case in the chance of being a terrorist and let him into your country.
Yeah.
In America, they will go very high on this. So what is the probability that you are like a terrorist? It's not that you're saying if you have a flag, erase the guy or pick him up and put him in jail.
Yeah.
No, but monitor it more carefully. That's basically how you should work with it. And if it's not, then unflag it.
Yeah, indeed. So I think here we only focus on one part, so the machine learning part and the analysis. But it should be part of your whole product vision, basically, or your whole solution vision, where you say, okay, this is the accuracy you need, but also this is the fairness that we want, and this is the case that we do. And then that's only this specific part, and then we have to look how we can change the system. So this is only one piece of the puzzle, yeah. And in this example, I show that if at the bottom I leave out the sensitive attributes, still the model is almost as unfair as it was before. So all these sensitive attributes are implicitly encoded in the rest of the data set. So just leaving it out is not enough. So how can we enforce fairness? So there's many ways, and here I'll show one example. So we start out with our normal bias classifier. So it's this bureaucratic robot, and it gets some data in. So the census data without the sensitive attributes. Its goal is to predict income from the census data. So the output will be the biased income predictions, and we maybe will measure how good the predictions are. So this is the current situation as we have it now. What we can add to enforce fairness is a fairness referee. So another robot or another classifier that works on the output of the first classifier. So its goal is to predict the sensitive attributes from the income predictions. And with that, we basically can see how well it can reconstruct our biases from the output. And it gives us a sense on how unfair the model is. And we can get this loss function or this cost function saying what the trade-off is between good predictions and detected unfairness. So how do we train this? So what's sort of the training loop for data scientists? So first we have a warming up where we train the classifier to predict income. So this is the standard approach. After that, the adversarial gets to detect unfairness. And tries to reconstruct these sensitive attributes as good as possible. And after that, we'll have this adversarial training loop. And this adversarial training is something that's been taken a lot from deep learning, where they want to generate new images, where there you have something that try to generate fake images. This is a generator, and you have a detector that tries to detect which ones are fake and which are from the original data set. And if you train them long enough sequentially, so after each other, you get to a situation where the discriminator is really good at detecting fakes, but also this discriminator is really good at generating fake images. So they'll look normal images to our eyes. And I think you've probably seen some examples on the internet about that, about fake faces being generated. So first, the classifier tries to be better at predicting income, but also being less unfair. Adversarial, again, tries to detect unfairness. Classifier starts again, adversarial, classifier, adversarial. So how do results look like? That's what you see here. So we have our graph back, but now it's changing over time. So here you see the training epochs. So first classifier, then adversarial training. And you'll see that over time, this P rule starts to change, and also the classifier performance changes. So the classifier performance decreases a bit, but also the P rule starts increasing. So the model is starting to get unfair, and you see that the whole distribution, so this probability distribution, giving to black and white people, but also men and women, will start to equalize. So the world is getting more fair. Is this clear to everyone? Okay, this was the most technical part of my talk, so that's good. So now about putting in the work. So this seems all rather easy. So you just let the data scientists do some more work and you'll get your fair models. It's actually not. So there's no real mathematical formulation of fairness. So there's no mathematician coming up to you saying, okay, this is fair. There's many, many metrics that you can choose. And there's also many conflicting metrics. So I got a paper there and they list around 20 metrics already that you can take. And from some data sets, they'll also result in fair data sets, and sometimes they won't. So this is another thing a data scientist has to think about for their case, which one to pick. There's also many fairness machine learning approaches. So there are basically 3 tiers: pre-processing, in-processing, and post-processing. So with pre-processing, you try to get the bias out of the data set and then feed it to your normal algorithm. In processing is what we did before. So during training, we try to change the algorithm. And then there's post-processing that acts on the output of the predictions, basically, and tries to reweigh them. And then I've only showed here around 9, but I think there's in the 20s, 30s, I don't know how many of approaches you can take. So it's a lot of work. And as we said before, I think fairness should be part of your product process, so of your whole bigger strategy. So at the beginning of the project, when you identify stakeholders, you might also already start to think about who might be harmed by this product. Who are they? How are they being harmed? And then the fairness approach, so how are you going to measure it? What's the interactions? So what decision are we going to make? Do we need any interventions anywhere? So there's a whole lot of things to think about. And I think this, don't know if you can see it, but I think my slides will be available later. That links to a slide deck from a collaboration, I think, of Microsoft, Google, and LinkedIn. And they showed of all the practicalities they run into when developing fair products. And what we see is that even with all these efforts, fairness is still far from being solved and needs active work still. So coming back to my original thesis, here we saw that in the beginning of the year, YouTube already said they will try to recommend fewer conspiracy theories. And then, this month we already saw that sometime YouTube's algorithm of the recommendations, if you've been looking at softcore porn, will lead you to videos of semi-nude kids, which of course something that's terrible. The same, I think, with the fire of the Notre Dame, that was tagged, I think, as a terrorist event, so with the details of 9/11 talk. So that's all kind of operations and things, how we influence the society that we really don't want. So even these big companies, they can't always practice what they preach. So it is really hard. So there are people on Google focused on it and they still cannot solve it. So if you look at the top 3 of their principles, so their objectives for AI applications, I think we can say that they won't always hold. So they are also failing. And they are top of the line machine learning experts. So what can we do? So I think in the end, we just have to put in the work to end up in machine learning hell. And it is a solvable problem. We just have to acknowledge our effect that we have on the society and what we can do and we can do not. And where to go from here? So I think a really nice thing you can already do, there's an ethics checklist for data scientists. So that's a tool that you can use that will generate a checklist at your project, asking you whether your models are fair, whether your data is GDPR proof, all that kind of stuff. So I think it's a really low level of starting. There's a tutorial on fairness for products that I mentioned. There's some blogs from us to read, so I have to promote those. And I think this book's really nice. So it's The Weapons of Math Destruction. I think it's already a classic. And it really talks about how all these big data and AI applications influence our societies in ways that we may not want. That was my talk. Thank you very much. So I think you got now for half an hour, so that's what we wanted. Are there any questions so far?
Show of hands. Any questions from the room? Yeah. You can try to speak up and I'll walk your way.
Can you actually solve it always? For example, well, we don't have it in the data sets, but let's say we now also get religion in these data sets. And suddenly you try to, and you see that this is indeed very unfair against certain religions, but you never thought about it. And then you have to come up with each different type of discrimination that you can think of.
Yeah, so good question. So I think one solution here is thinking of the whole loop. So it's not only the data and the machining part, but at the beginning, think of this strategy. How can we? Who is the stakeholder? How can you account for that? On the technical part, I've seen now some new papers that are being released, and they try to identify these sensitive groups from the data by itself, without explicitly being there. So there's research being done.
Any more questions?
I really like your stuff. The questions in my mind is society is unfair, I think, today. I don't think we agree necessarily all what is fair and unfair. So how do you get that ethical debate basically in your decision? So I like that you can show, for instance, female is an indicator whether you predict high income or lower, like in your example. I think we agree that's not fair.
Yeah.
But there's some things that, for instance, when you have jobs and sustainability, you might say, well, we need a lot of jobs, which is fair, but it will decrease sustainability. And someone else say, well, sustainability is more important. How do you incorporate these ethical things and where people, it's more like a political discussion, not necessarily agree?
Yeah, so exactly how to incorporate, I don't know, but it is indeed just a political discussion. And I think that's also what we need to acknowledge as a field, that what we do is not neutral. It's not just the data as it is with our neutral algorithms that give unneutral predictions because of the data. It's because of us. It's because of the things that we designed. And I think, yeah, that's why we need in every loop of this development, we have to think about what the impact can be and what we may and may not want. So, yeah, at least be open about it. And I think there's also cases where you can indeed say, okay, we want to be unfair here, but then it has to be a decision instead of something that just comes up.
Thank you. That was a nice presentation. My question is around, are you aware of any frameworks created by big companies? Like you mentioned Google, but I was wondering, what about Microsoft, Salesforce, Adobe, coming together? They're coming together with the Open Data Initiative. I don't know if you're aware of something similar in this area.
So I've seen some open source frameworks from I think Microsoft and IBM and also Google. So extra data science, you can actually use it. And there's also some academic code. So that's good. But here also, it's often like this one-off effort where they open source this utility package that you can then use. But I haven't seen, really an effort where people are continuously driving it. So there's this fine line between doing something good and continuously doing something good, I think.
Can you hear me?
Yeah.
I find it striking the example from the Dutch government that actually it's the people at the end of the food chain who actually get affected by this. And I know from the book of Cathy O'Neill that actually the scientific journalists are the ones who have to point out when things go wrong. I think it's admirable that and very important that individuals build right models, but I think as a society and as companies, I wonder how far we are in auditing these models, so either within an enterprise or at a sort of national level. I don't know what level that would be. I'm very curious what your thoughts are on that, because I think we're moving towards a situation where you want some kind of independent organization who's going to judge or audit these models, especially if they have a big societal impact.
Yeah. So I think in the US there are also already some laws. So for instance, I think there's the Housing Act saying you're not allowed to use race there. And there's there was, I think, a scandal about delivery where there was a redlining of neighborhoods where you couldn't get same-day delivery. And it was also not allowed. So I think there has to be a force to drive this somehow. It cannot only be scandal-driven.
You almost need some kind of, like in science, you have a referee of a model of your paper. In modeling world, you need some kind of referee that's going to check these models before they go out into some form of production. But I wonder what kind of movements are happening, what kind of thoughts there are like that.
So yeah, I don't know, especially for this topic specifically. I don't know. I do know that some financial institutions, I think their models are checked. So I don't know if fairness is also checked. So that's then the question. But I haven't seen any official way. So there are now, I think, ideas also in the EU about forming a commission thinking about this. But there's some laws, but no general guidelines, as far as I know.
I do recall having Stijn here talking about in the US models that need to have a certain fairness and accuracy level.
Yeah, so this, for instance, this P rule is also from, I think it's, you have to have 80% for things like housing.
Yeah.
But it's not for all areas. I don't think as a website like YouTube is necessarily officially regulated.
Right. Okay, one final question from the room. Yeah.
I was just wondering, can we use multi-objective optimization instead of ending up with one model, you end up with multiple models, and each model can be evaluated for fairness and accuracy, and then you basically evaluate and try to find a balanced model that is both fair and accurate?
So is it then one model doing multiple stuff, or is it multiple models?
Like the solution that you had the loss in the first model, and then another model was checking the fairness.
Yeah.
But instead of having this loss, if this function is multi-objective, then it can split up, how fair is the model and how accurate is the model. And then in the end, you end up with a set of solutions.
Like that.
One will be very fair but not accurate, and on the other hand, very accurate but not fair, and maybe in the middle we can find.
Yeah, so I have only seen stuff that iteratively tries to adjust the model in a training approach like this, and it can be many ways. So you need first do accuracy and then reweigh the examples based on how unfair they are or how unrepresented they are. So there are things like that. But I haven't seen something that really gives the whole formulation of, if you take this threshold, you're that unfair and so performant. But I think it's a really active field of research also.
Henk, thank you very much for this insightful presentation.